Hi people, notes 5.1 are on compound angle formulas and what a compound angle formula means. So if I have an angle that I can say is the sum of two angles together, then I can find the cosine of that angle by using this formula. If I have an angle that is the difference of two angles, I can find the cosine of that angle using this formula. If I have an angle that is the sum of two angles and I want to find the sine of that angle, I would use this formula. I would use this formula if I want to find the difference. And then the same thing is true for tangent. And I'll explain to you more in detail what I mean by all of this as we go throughout the lesson. But you just want to be careful because you have to use these formulas, because a common mistake people will make is they'll think cosine of x plus y is just going to be cosine of x plus cosine of y, which is not true at all. All right, so let's take a look at our first example here. It tells us to express as a single trig ratio using an appropriate compound angle formula. If you notice in question A, we've got cosine of some angle times the cosine of 2 theta, and then we've got minus sine of theta times the sine of 2 theta. And if you notice, this theta right here matches with this theta, this 2 theta matches with this 2 theta, just like over here, this x matches with this x, and this y matches with this y. And if you notice, this says cosine, cosine, this says sine, sine, and the one that also says cosine, cosine, sine, sine is this either cosine of x plus y and cosine of x minus y. Now, because this says minus here and this says minus here, it means we would be using this formula. So what does that mean? That tells us that the cosine of theta times the cosine of 2 theta minus the sine of theta times the sine of 2 theta is equal to the cosine of these two angles added together. So this is just plain and simply the cosine of 3 theta. Now, if you notice in part B, it says tan of pi over 3. So we've got this tangent right here, and then we've got minus the tangent over here of pi over 4, and that looks a lot like what we have right here. And then we've got a 1 right here, which also matches up with this 1 plus right here, and the signs in the numerator match up. And then we have tan of pi over 3 that match, and then tan of pi over 4, which matches with tan of y. So this is clearly the formula that I want to use right here. So this means that this whole entire thing is going to be equal to the tan of the first angle, which is pi over 3, minus the second angle right here, which is pi over 4. And I know to use minus because this matches up with this, and this says to use minus. All right, cool. So now I just have to figure out what this is going to be. So the tan of pi over 3 minus pi over 4, at this point in time, it is literally just fraction work. So they have a common denominator of 12 multiplied by 4 on the left fraction, multiplied by 3 on the right fraction. So I get 4 pi minus 3 pi all over 12, which is pi over 12. So this right here means that it would be tan of pi over 12. Now, this next one right here says to determine special angles that add up to, our first question is 165 degrees. And special angles are always going to be the angles that are on my unit circle. So like 30 degrees, 40 degrees, 60 degrees, anything really along these lines right here, these are all considered special angles. So I'm trying to get 165 degrees. And I want two angles that I can add up together to give me 165, or two angles that I can subtract to give me 165. So for example, I could say that 165 is 180, which is one of my special angles, but then it would be minus 15, which is not one of my special angles. So this is not something that I would want to use, for example. So 165 is going to fall somewhere in this area right here. So I maybe would want to use some of the special angles around here. 150 I still wouldn't want to use because that's 15 away, and that is not going to be a special angle that I can use. Let's try 135. So 165 would be 135 plus 30 degrees. Both of these are special angles, so that is one possibility that I could have used. I could have also used this 120 right here, because 120, if I add 45 to that, would also give me 65 degrees, okay? So we've got two possible answers here. We could either say that it's equal to 135 degrees plus 30 degrees. We could say that it's equal to 120 degrees plus 45 degrees. We could have even worked backwards and said that this was like 210 degrees minus 445 degrees. So we've got a lot of different options. I only put 2 down. You can put down as many as you'd like. Now for negative 19 pi over 12, this time we need to choose angles in radians. So for starters, one option that I could write down, for example, is I could say that this is equal to negative pi over 12 plus 18 pi over 12. But the problem with this is that this negative pi over 12 is not a special angle. So I need to break this up into things that I know would become special angles. And remember, our special angles in radians are always like pi out of 6, pi out of 4, pi out of 3, pi out of 2. So we've got denominators of 2, 3, 4, and 6. We don't have denominators of 12. So what I want to do is I want to choose angles that I know when I divide it, and I apologize, I meant to say negative pi over 12 minus 18 pi over 12. So I want to choose angles that when I get these angles, I can reduce them to get out of 2, out of 3, out of 4, or out of 6. So for example, I could do negative 3 pi over 12 minus 16 pi over 12. Why did I choose these numbers right here? Because negative 3 minus 16 gives me negative 19. But also because I know that 3 and 12 have something in common and 16 and 12 have something in common. So I can reduce them. So like if I were going to reduce this, they're both divisible by 3. So I would get negative pi over 4. And then if I were to reduce this right here, they're both divisible by 4. So I would get negative 4 pi over 3. So these are some special angles that I could add together. Try to see if you can find another one, and we'll talk about it next time we see you in class. All right, so the next question asks us to determine the exact value of each using a compound angle formula. So the first one that we have here is sine of 13 pi over 12. So the first thing that we need to do is determine two angles that we can use that will help us to determine 13 pi over 12. So again, we'll split this up into something out of 12, but we want to use values that we know will reduce to have denominators of 2, 3, 4, or 6. So like I could do 1 plus 12, but that won't work. Because 1 over 12 doesn't work. I could do 2 plus 11, but 11 over 12 won't work. I could do 3 plus 10 because 3 over 12 reduces and 10 over 12 reduces. So that's one option. I could do 3 pi over 12 plus 10 pi over 12, which would turn into pi over 4 plus 5 pi over 6. I could also do 4 pi over 12 plus 9 pi over 12. Like there's lots of different options, but this is the first one that I thought of, so this is the one that I'm going to do. And I'm actually going to color code this so you can see what's going on here. So here we can say that sine of 13 pi over 12 is going to be equal to sine pi over 4 plus 5 pi over 6. And if you remember, we can use this formula right here that it's sine of x cosine of y plus cosine of x sine of y. So what this means I'm going to do is sine of pi over 4 multiplied by the cosine of 5 pi over 6 plus the cosine of pi over 4 multiplied by the sine of 5 pi over 6. Okay, and then I can just use the unit circle right here, and I would be using this and this. Okay, I'm not going to go over how to use those just because that is from the previous unit. So we know that the sine of pi over 4 is root 2 over 2. And we also know that the cosine of 5 pi over 6 is going to be negative root 3 over 2. Plus, the cosine of pi over 4 is also root 2 over 2. And then I'm going to multiply that by the sine of 5 pi over 6, which is 1/2. Now I just need to go ahead and evaluate this. So root 2 times negative root 3 is negative root 6. 2 times 2 is 4. And then root 2 times 1 is root 2. And then 2 times 2 is 4. because they have a common denominator, I can say my final answer is negative root 6 plus root 2 all over 4. And I am done with this question. And remember, it wanted an exact answer, so I'm going to leave it as roots right here, as radicals. All right, we want to do the same thing right here, cosine of negative 15 degrees. So the first thing I need to do is decide what negative 15 degrees would be using our special angles. So negative 15 degrees, I could say would be one possibility that I could do is 30 degrees, and then I would subtract 45 degrees. And that would give me negative 15. So here I could say that cosine of negative 15 degrees is equal to the cosine of 30 degrees minus 45 degrees. Notice how every single time I'm putting in degrees, so I indicate that we are in degrees this time and not in radians, okay? And if you look back up here, and the formula right here for cosine of x minus y would be cosine x cosine y plus sine x sine y. So this right here would end up being cosine 30, cosine 45, and then for the cosine angles, it's always the opposite sign, so this would be plus sine 30 degrees, and I just said put degrees, and I totally forgot to, sorry about that, times this, the sine of 45 degrees. Okay, go to our unit circle, and this time we would be using this information right here. So we know that the cosine of 30 degrees is going to be root 3 over 2. And we know that the cosine of 45 degrees is going to be root 2 over 2. Plus, and then here we've got the sine of 30 degrees would be 1/2. And then the sine of 45 would be root 2 over 2. And then when I multiply all of these together, I would get root 6 over 4 plus root 2 over 4, and then we have a common denominator. So my answer right here would be root 6 plus root 2 all over 4. Notice that cosine of negative 15 degrees would be in the fourth quadrant, and cosine is always going to be positive in the fourth quadrant, and this is a positive answer. So we know that this is, we have a better idea that this is right. All right, our last example is asking us to find sine of a plus b, cosine of a plus b, and tangent of a plus b, where a and b are obtuse angles. This is going to be important to us. And that we are also told that the sine of a is 3/5 and that the sine of b is 5/13. So notice how sine is positive in both of these problems right here, in both of these ratios, I should say. So we've got a positive sign here and a positive sign here. However, if you notice, the angles have to be obtuse. So in our first box, it says here, let's get some more information. I'm going to draw out a triangle with angle A, and I'm also going to draw out a triangle with angle B. And because I am told that the sine of A is equal to 3/5, but A is obtuse, that means that we are talking about the second quadrant. Because if I have an obtuse angle, it has to be more than 90 degrees, right? So this right here is what this would look like. Now remember, sine is always going to be opposite, which is here is the related acute angle that we're talking about. So the opposite would be this side length right here over the hypotenuse, which is 5. Or remember, sine can be y over the radius right here, y over r. So based on that, I can go ahead and actually figure out or what the missing side is in my triangle right here. So I could use Pythagorean theorem, plug in my information right here. So I'd say 3 squared plus b squared equals 5 squared. So 9 plus b squared equals 25. B squared equals 16. So b equals 4. But hopefully you already knew that that was a Pythagorean triple. Okay, so what information is that going to give me? Well, now I know what cosine of angle A is. And cosine is going to be -4, because it is to the left of the y-axis over the radius, which is 5. And I'm color coding this with one color for a reason. And then the tangent of angle A would be the opposite over the adjacent, or the y over the x, and it would be 3 over -4, or we could just simply say -3/4. tangent's always going to be negative in the second quadrant. We want to do something very similar with the other ratio that's given to us. So the other ratio, it tells us that sine of A is going to be equal to 12 over 13. Sorry, I meant to say 5 over 13. And it's still positive, but it's obtuse, so this would also be in the second quadrant. So this is what this looks like right here. So the opposite is 5, the radius is 13. So I could do Pythagorean theorem again to solve for my C value right here. So 5 squared plus B squared equals 13 squared. I'm going through this pretty quickly. Knowing those Pythagorean triples is also really helpful because then you don't have to do any of this work at all. So here I know that little b would be negative 12. So we know that cosine, and I apologize, this should not be sine of A. This is angle B now that we're talking about. So the cosine of angle B would be negative 12 over 13 because the x value is going to the left. It's in the second quadrant. And then tangent of B would be the opposite, which is 5 over the adjacent, which is negative 12. I'll just put the negative in front. This information is going to help us out with everything else going forward from here. Now notice, I didn't need to actually figure out what angle A and what angle B are. And the reason why I don't need to know what they are is because if we look back at our formula, sine of A plus B would be equal to sine of A cosine of B plus the cosine of A sine of B. And notice when I do this, I have all of this information right here. We're given sine of A. We are given cosine of B. We are given cosine of A. And we are given sine of B. So all of that information is given to us without actually knowing the angle. So it's a little bit different than these two examples here because we actually had to figure out what they were based on a specific angle that was given to us. Now we're given a ratio and we use that ratio to find the other sides of our triangle without even needing to find the angle at all. So now all I have to do is just fill in that information right here. So here I can just say sine of A is 3/5 and I'm going to multiply that by the cosine of B, which is negative 12 over 13. And then I'm going to add the cosine of A, which is negative 4/5. And I'm going to multiply that by the sine of B, which is 5/13. And then all I have to do here is just simply evaluate. So I'm going to multiply across. 3 times negative 12 is negative 36. 5 times 13 is 65. Negative 4 times 5 is negative 20. 5 times 13 is also 65. Put those together, you get negative 56 over 65. And you can't reduce it. So that is what sine of A plus B would be. Now, to find cosine of A plus B, it's the same thing. I don't need to find the angles. I just need to use the formula for cosine of A plus B. So cosine of A plus B, I'm going to color code it this time, would be cosine of A multiplied by the cosine of B. And then remember, cosine is the one where you do the opposite sign. So I'm going to say minus. And then here I'm going to do sine of A times the sine of B, okay? And then I'm just going to fill in all of that information here. So I know that cosine of A is negative 4/5. And I know that cosine of B is negative 12/13. And then I'm going to write down minus. And then here, I know that sine of A is 3/5. And that's going to be multiplied by the sine of B, which we know is 5/13. So let's go ahead and just evaluate this right here. So when I multiply across, I get 48 over 65 minus 15 over 65. When I put the 48 and the negative 15 together, I get 33 over 65. I can't reduce this anymore. So this is what cosine of A plus B should be. All right, and then let's go ahead and do tangent right here. So tangent of A plus B would end up being, this is where I would have to use the formula right here, where it is tangent of A plus the tangent of B all over 1 minus the tangent of A multiplied by the tangent of B. And this is where we're going to have some fractions within fractions. So let's go ahead and fill in that information right here. So the tangent of A would end up being -3/4. So I would put here -3/4. And then I would write plus the tangent of B, which is -5/12. So I can just write -5/12. And that would be all over 1 minus. And then I'm going to multiply tan of A and tan of B together. So I would multiply -3/4 by -5/12. I'll zoom in on this now. So this would end up becoming, just going to keep this -3/4 on top, this -5/12 on, and I'm just going to evaluate my multiplication right here. So I'm going to evaluate this right here. So -3 times -5 would end up giving me positive 15. However, there's this minus sign right here. So the 3 negatives would still stay negative. So I would write down minus, and then I would get 15 on top over 4 times 12, which is 48 on the bottom. Okay, so then I would go ahead and I don't like my fraction, so I'm going to go through, I'm going to clear my fraction. So I'm going to multiply by an LCD, which is 48 right here. I'm going to multiply every single term here by an LCD. So all of my numerator, all of my denominator. When I multiply -3/4 by 48, I would get -36. And when I multiply -5/12 by 48, I would get -20. And then in the denominator, 1 times 48 would just be 48. And then 15 over 48 times 48 would be 15. So I would end up getting -56 over 33. So my answer here would be -56 over 33. That is the tangent of A plus B. Now, just a quick note, I could have used this formula and done all that work and done just fine. But don't forget that the tangent of A plus B is equal to the sine of A plus B over the cosine of A plus B. And we figured out here that the sine was -56 over 65. And we figured out here that the cosine was 33 over 65. And we could multiply by 65 over 65, cancel, and I get -56 over 33, and I get the exact same answer. And that's it for this video. Let me know if you have any questions. Otherwise, I'll see you in class. Bye.